So before I get to the fastener industry, I'll talk to you a little bit about how I got there, because I'm now in the fastener industry for 30 years. 30 years. I had no idea what it was about. And I'm still learning every day. So that job at Galvano happened to be a job where I was working for a division that was doing the coatings. So they applied zinc, plating or galvanizing or different types of coatings on the bolts that another factory in Fasco used to make. So I spent 7 years there, and I was so lucky because it was a small company, a small plant. There was only like 45 employees. We worked 3 shifts, and I was young, and I could do whatever I wanted because it was small. So there were no boundaries. I could learn about everything. So I wanted to learn how every pipe, every valve, every system, every controller, how everything worked and what it did in the plant. And I spent time doing that. I spent time just asking questions, learning, helping. Whenever somebody came to me with a problem, I didn't have all the answers, but I would figure it out and help them and go back and say, yeah, this is how we can make your job better, or your job easier, or your line more productive. And it didn't come that, that wasn't my main sort of objective throughout. I learned that that's what I need to do because my boss at the time said, you need to learn the process. You need to learn what we're doing here. You need to learn everything that you can. And that's true whether it's in this plant or that job or whatever the job is. So take the time to learn. So 7 years there, and then I was doing well, loving it, wonderful. I even had an opportunity to become the plant manager over there, and I was still a little bit on the young age, and so Mr. Bahadrian said, better thing is for you to come to the mothership, to Fasco, which is the big plant where they make the fasteners. Now this is a huge factory, and spend some time over there and learn how we make the bolts. Okay, so I spent 3 years there and learned as much as I can, and so on and so forth. And then lo and behold, I get calls from headhunters. Now I'm at a point in my career where my profile is attractive to a whole bunch of different companies around the world making fasteners. So I get some calls from a headhunter from a German company that had a facility in Michigan making critical fasteners for the auto industry. Because Fasco makes bolts that are used in buildings and structures and that sort of thing. I said, okay, sure. And the next thing I know, one thing leads to the next, and I get hired, and I'm moving to Michigan. I'm the director of engineering of this company called CAMAX in Michigan. I spent 3 years there. I learned a lot, as much as I could, because it's a whole different world, the auto industry. Living in Michigan, it's like, the auto industry is everything in the Midwest, but especially in the Detroit area. You make contacts, you make connections, and whatever I learned over there opened up a whole bunch of other doors to me. So at that point I had been working for about 13 years, and I said, okay, I don't really want to live in Michigan. I really love Montreal. I want to go back to Montreal, but my career is going this way, and going back to Montreal would be a step backwards unless I go to Fasco. But yeah. So what I did, I said, okay, the only way I'm going to do this is I'm leaving Michigan to go back to Montreal. I'm going to start my own company. I'm already getting a good sort of reputation. People are learning who I am, and I could build on a consulting business. But I was also very much intrigued by this subject called hydrogen embrittlement, and I said, okay, I also want to become an expert in that field because I'm already well known for it, but I need some more expertise. So how to do that? I've been working with Steve Yu to propose a research program on hydrogen embrittlement. What I did is, once I started out on my own as working for myself, I went out to the industry and said, hey, we got some problems in the industry with hydrogen embrittlement. Why don't we all put some money in a hat, and that'll help me lead this project that's going to give us some fundamental answers. And companies are interested. I got money from a whole variety of different companies, including Boeing. See, next door opens. So got some money. We got a grant from NSERC, And then I started, and I was doing my master's, and then that led to doing a PhD while working and running my own company and all over the map. And by the way, you know, having kids and all that stuff is happening in life. So a challenging time, but I wouldn't have had it any other way. And that's what I wanted to do. But one thing led to the next. If you had told me when I was leaving McGill, graduating, that you were going to follow this path, I would have never guessed it. The only thing that I did know is at some point I want to work for myself. At some point I want to have my own company. And a very close friend of mine, Dr. George Kim, who's also a graduate from this department, you know, we kind of had these ideas and we said, oh yeah, one day we're going to start our own company. And yeah, lo and behold, he did the same thing. He has his own company, Perpetual Technologies, similar to mine, where we do consulting, we do research, and by the way, we're partners in, you know, in a little bit of a startup that we started on our own too. So we created that visual path, but we didn't have any idea what you know, road we were going to take to get there. And really, it's all about taking the opportunities that come your way, making the most of them, and that opens up more doors. It's a positive way to approach things. So with that in mind, I'm going to talk to you a little bit about fasteners. I've been in this business for 30 years. I'm still learning. You know, I don't like to, you know, gloat or brag, but I'm one of the few technical gurus best known around the world in this industry, and I'm right here, okay? 30 years in the business, and I'm still learning. I'm still learning. Why? Why do you think fasteners makes it so challenging and so interesting to learn about all these things? Well, primarily because they're used everywhere. They're used in all sorts of applications. So I don't know if you're going to see the screen. Yeah. So this is the Champlain Bridge, the new Samuel de Champlain Bridge. Millions of fasteners used on that bridge. How many bridges do we have around the world? How many bridges do we have in Canada? How many bridges do we have in Montreal? Not all of them are that, you know, glamorous, but there are a whole bunch of them, and you need people who not only know how to make the fasteners, people who know how to use the fasteners, people who know how to design the joints, the bolted joints. Aircraft, different aircraft. You can imagine whether it's a civilian airplane or a military airplane, or if it's a helicopter or whatever the case is, there are critical fasteners. There are fasteners holding all of this together. Bolts, nuts, screws, rivets, holding all of it together. And if one of them fails in a critical position, it's going to cause a catastrophe. Cars, trains, stadia, large equipment. Fasteners are everywhere. I told Jenny before, you know, starting my little talk here, if I just took you guys outside, just outside here, outside of the building, and you look around a little bit, you'd be amazed at where fasteners are being used. Look around you, this building. It's got a steel frame. The steel frame is held together with bolts. The chairs you're sitting on, the tables you're using, everything is held together with screws and fasteners. So what I'm trying to say is, the reason why I'm learning still to this day is because the fasteners are as complicated or as simple as the joint or the application where they're being used. And I'm always learning about a new application. So fasteners are sophisticated components because they're designed to clamp a bolted joint together. And how they work depends on the strength level of the fastener. So there are different categories of strength levels. There are different sizes and shapes. But basically the fastener, as it's being tensioned in a joint, it stretches, and as it stretches, it creates a clamp load. And the clamp load is designed to overcome the separation forces. So if you have a joint that wants to open up and do this, the fastener has to be strong enough to overcome that. So that's the whole key to designing a joint. And it's never one bolt and one joint, it's a whole array of bolts in a very sophisticated joint. So So a lot of things can go wrong, and when they do go wrong, fasteners will break, and when they break, that often causes a catastrophic accident. So here's one example of what I've been involved in. I've been involved in bolts that are breaking on offshore oil platforms in the Gulf of Mexico. You see it made the headlines in the Washington newspapers and the Wall Street Journal too. And this happened 2 years after the BP oil disaster, and you can imagine people were really concerned because these are about, you know, anywhere from 1 inch to 3 inch diameter bolts, high strength bolts that were breaking in subsea applications on a component that's called the blowout preventer. And they don't want, you know, this blowout preventer is supposed to prevent the oil well from overflowing if something happens or something goes wrong. It just shuts the oil well. But these bolts were used in that blowout preventer, and they were breaking. And it caused a lot of concerns because they were breaking on oil platforms all over the Gulf of Mexico. And you know, all these operators of offshore oil platforms around the world got seriously concerned, and they started panicking, and they started changing things all over the place. That's one example of what I've been involved in. You wouldn't think fasteners. Talk about another one. This one was the Bay Bridge in San Francisco. This bridge was built to replace an older bridge that partially collapsed when there was an earthquake in 1989. That's the bridge, the old bridge. And in 1989, that bridge collapsed in the Loma Prieta earthquake, and it caused some people to lose their lives. So the city of San Francisco and city of Oakland and the state of California decided we need to build a new bridge. There's no way to reinforce that one, so they built this new bridge. It was a 7-year project. It's the span over here. It connects Yerba Buena Island to Oakland. You have another bridge that goes from there to the island itself. And I got involved because I was working with the constructor, the contractor who was building the bridge, and helping them design a new bolted joint. And the research that we were doing here in McGill was helping them make some choices, and they needed my help to figure out how to install bolts with a specific type of coating. So I was involved on the bridge for a few years. And then when I thought my job was done and I was happily moving on, I knew the bridge was a few months away from opening, they gave me a call and they said, hey, can you get over here yesterday, because we're having some problems with the anchor rods breaking all of a sudden as they were being tensioned. They were being tensioned when the bridge was being anchored into place, and within a few days these anchor rods were breaking. And it caused a major panic with the community over there. It was in all the newspapers. We were getting phone calls. People, reporters were calling me and hounding me to try to see what was going on. I was involved. I led the failure investigation on that project. That took 2 or 3 years to kind of close out, but a very high-profile failure case that I was involved in. Another example. I talked about the in New York, the Freedom Tower. That's another one that I was involved in where bolts were breaking. I've been involved again with projects that are not as high profile, but with the auto companies, with GM and with Ford, is designing new materials for fasteners to be used in high strength joints, because what are we doing in cars? We're trying to reduce weight, and so that means trying to find materials that are going to perform at higher and higher strength, which means we can use smaller fasteners that are higher strength to redesign joints. We've been doing a lot of work here at McGill and myself to help these companies develop these materials. One of our biggest sponsors for our research programs here is Boeing. Boeing has funded a lot of work that we've done on a lot of our students, and that's all focused on the fastener aspect. That what we're doing with fasteners is even translating to their landing gear. So that opened up doors for me to do work with Messier Doughty, with Hera DevTech, who build landing gears for aircraft. The opportunities with fasteners are wide and broad. And so there's no limit to it. It all depends on whether you really want to go into an industry that's manufacturing or not. Now, the specific opportunities with fastener industry, and with the manufacturing base in North America altogether, with guys your age, there's a tendency to focus more on what's quote-unquote sexy, and manufacturing is not, right? It's a basic, fundamental need. A lot of our manufacturing base is being shifted over to the Far East, to China principally, but that means that North American manufacturers, to be able to compete, have to make higher-end products, more value-added products, more, develop more expertise, and there is a need for not just engineers, but anybody to go and work in a plant. One of those bolt makers that I was talking about, to learn how to operate one is like becoming a pilot of an airplane. It takes years. It takes years and takes expertise. And those guys, they don't have a university education, the guys that are operating these machines, but they're at the high end of the totem pole. They make more money than the engineers for the most part, because it takes that much expertise and know-how to operate one of these pieces of equipment. We need those all over North America. Fastener manufacturers need people to go into the plant and to be able to operate equipment and machinery. For you guys, there are opportunities all over North America to work, and I would say the world, to work for fastener manufacturers, because they need young people to come into the system and to learn and to stay and to grow with the industry. Yeah.
I would guess too that with a lot of the workforce retiring out, there's a lot of room for rapid promotion.
Absolutely. Provided you roll up your sleeves and you work, you're going to succeed in no matter any industry you get into. But to Jenny's point, there's a hollowing out of knowledge. A lot of people who have a lot of years of experience are retiring. And so now these companies are left with, few people who know what they're doing, and they can't necessarily attract all the right types of people. So there's a lot of opportunity to grow quickly and to move up quickly, provided you're ready to work and learn. So Infasco, like I said, is a manufacturer of fasteners, one of the largest in the world. They make standard fasteners, so not specialty product. So it's high volume. From a metallurgical and material science perspective, it's very interesting. Their products go into every big structure around the world. I mean, they literally get used all over the world. And you know their product because it has a triangle on the head. All fasteners are manufactured with the manufacturer's ID, and they all have their own registered trademark IDs. Infasco's is the triangle. There are 3 companies in North America that compete on that market, and Infasco is one of them. And like I said, their products go everywhere. They go into heavy equipment and machinery, and they go on the bridges and the structural business. They sell product, even to Harley and to John Deere and to Caterpillar and so on and so forth. So there's a lot that they do, and but really it's a factory that's making fasteners on high volume, which means from the metallurgical perspective, there's a lot to learn, because you're taking steel and you need to soften it to be able to forge your part, and then after you soften it, you have to heat treat it to give it strength, and then you have to put a coating on it to give it certain corrosion protection properties. So there's a lot there that you could learn from.